Hey guys, I'm hanging out with Beaker since I brought him in, and we're going to go over Electron Configuration, Chapter 7, which should not be new material for you guys, so hopefully we'll fly through it and you can get your notes done and be on to doing some more fun stuff than this, okay? So, Electron Configuration, there was that guy Rutherford, he discovered the nucleus and said that electrons moved around it, okay? And this is what we basically think of when people think of an atom. That's what they think of, okay? We know that's not exactly what it looks like, but it's a pretty picture to put in our head, okay? And then Bohr came along, and he said that we have these energy levels, that the electrons exist in energy levels, and we still talk about these energy levels today. And you've got your n equals 1, n equals 2, n equals 3, and as you go further and further out, the energy level number gets higher and higher. And as you get further and further out, these electrons have more energy. I always talk about this like children, okay? Children who are real close to their parents, right? You maybe are holding their hand and they can't get very far away from you. There's not a lot of energy. But if they get tons and tons of candy and they break away from your hand as they head out further and further from their parent, more and more energy. Okay, so super excited little kids. And I want to talk about real quickly, since we're on this slide, and it's a nice place to do it, that, you know, the whole sugar rush principle. When you heat up an electron, let's say there's an electron right here, and you heat this guy up, you put some energy into him, he has more energy, he can move out further to these further out energy levels. As he moves out to these further out energy levels, he can't stay there forever because it's like a kid on a sugar rush. You give them candy, they get all excited, they're bouncing off the walls, but eventually they are going to fizzle back down, okay? And when they fizzle back down, remember, they emit light. This was that whole, remember when we did the flame testing in regular chem, okay? That was because those electrons got excited, jumped up a level. When they come back down, they emit the light, okay? All right, quantum mechanical model. There are different kinds of orbitals. Within the n equals 1, n equals 2, n equals 3, you've got your S, your P, your D, your F, okay? Hopefully you guys remember this from last time. They have all different shapes and sizes, and they have different energies, okay? Principal energy levels are the energy levels of electrons, and they are represented by the letter N, okay? As N increases, the energy of the electron increases. Just like we said in that Bohr picture, the further you got away from the nucleus, okay? If this is our little nucleus, the further out we get, the more energy there is. We increase energy that way, okay? As N increases, energy increases. Each principal energy level is divided into one or more sublevels. So we've got sublevels now. The number of sublevels in each principal energy level is equal to N. So if N equals 1, there is one sublevel. If N equals 2, there is 2 sublevels. If N equals 3, there are 3 sublevels. Still having problems with switching my slides. There we go. And I went backwards. Backwards doesn't work for me. Okay, so here is an s orbital. There are different kinds of orbitals, s, p, d, and f, we said. This is what an s orbital looks like, okay? It is a sphere, and the s orbital can hold 2 electrons, okay? It is spherical, just like it shows here. And I like this picture right here because this kind of helps you understand why we say it's spherical. Now,